Let's talk about JDBC, or Java Database Connectivity. So up to this point, we've been interacting with the database manually, sitting at a console, directly sending commands to the database to insert, update, delete, create tables, and that's fine. But we would like to consider other ways, perhaps a more abstract and create a layer of abstraction that would allow us to interact with it a little easier. Right? It has obviously there's a lot of idiosyncrasies depending on which vendor you are using. There are different dialects. There are different things that you have to consider. Going from one vendor to the next. And so we would like to be able to encapsulate all those idiosyncrasies and have perhaps libraries interact with the database for us, right, as opposed to us directly. And so we're going to be talking about JDBC as a first layer of abstraction. Right? We're going to be creating more and more abstractions. And I mean, a database is already an abstraction. All right, right? There are no real tables or records, right? Those are all concepts that we invented, right? That underneath is just file system, right? Zeros and ones. And then on top of that, we've created this conceptual way of thinking about the data, right? In terms of these flat sets of data points that somehow are related to one another, and we called it relational databases. Right? And then we wrote we created this language that allows us to interact with the data in a structural way, right? And I mean, a select statement basically is an abstraction of some for loop that is iterating over some data set that is looking for something, right? That it's comparing all the records against some predicate, right? A select statement gets compiled, right? Gets interpreted, gets parsed, right? And then the parameters and the names of the tables and the predicates are used for this very generic loop that is iterating over records that are read from some file, and then identifies which records in what file matches those predicates, right? And then retrieves them from them, and then it formats them in this nice little table with fields and whatnot. Make sense? So a database is already a layer of abstraction. So we're going to create another layer of abstraction on top of that. The first layer of abstraction we're going to consider is JDBC, or Java Database Connectivity. So JDBC falls into the same category of strategies that the Java programming language, introduced early on, right? The mantra of Java was that you code once, right, and you run everywhere, right? That was the intent. That they would provide a layer of abstraction on top of an operating system, right? So that you could code to this virtual machine, right, without having to deal with the idiosyncrasies of whatever actual operating system you were running on, right? As long as you stuck to a particular high-level API, right, which is the JDK, the Java Developer Kit. Yes. So JDBC, the philosophy of JDBC is the same thing, right? It's going to apply what Java was for the operating system. JDBC is for the database, right? The idea is that instead of programmatically interacting with the database, with the idiosyncrasies of the select statements and the dialogue and the dialects of the different vendors, instead, JDBC would provide a high-level API. Right? It would abstract the database in terms of certain libraries, right, certain classes, and then you could program to this high-level API, and everything will be translated into the low-level idiosyncrasies of different vendors. Okay? And the way it was done is that JDBC provided an interface, a set of classes and interfaces that represented database connections, database statements, statements such as selects, updates, delete, and whatnot. Yes. Then it represented result sets, the results that came back, that represents those rows. Right? And then with these 3 or 4 interfaces, you could presumably interact with any database. Right? Then it was the responsibility of each vendor that wanted to participate in the JDBC world could write their own implementations of these interfaces, right? Which would hide all the details and idiosyncrasies of how each database vendor actually worked. Okay, there was some pushback to this. Just like perhaps there was some pushback when Java first came out, of saying, wait a minute, what do you mean the operating system doesn't matter? Right? From the operating systems vendors, the operating system was everything that mattered. Right? If you told Microsoft that Windows didn't matter, right? That the language abstracted the operating system, then obviously Windows didn't like that. It says, what do you mean? No, the operating system is the infrastructure, right? It's my bread and butter. And so there was a lot of pushback, from the different operating system folks, first to the Java language, and then now in the JDBC space, right? In JDBC, a lot of the database vendors, somewhat balked at this idea that they would be converted into a commodity, right? That it doesn't really matter which vendor you're interacting with, it's all abstracted into this high-level API, right? And folks would be insulated from the vendor because they would always write into this particular API. Make sense, right? So database vendor again didn't like this much, but nevertheless, right? They do provide connectors or adapters that implement this the JDBC API. Vendors will go out of their way to offer certain features, beyond the basic API that is JDBC, and they will typically provide those features in a separate set of libraries in a separate package, right? And usually off of instead of the .java, maybe a Java X for extension or extendability, and they'll try to convince you to use these more advanced features that are specific to their particular vendor, that specific brand. But the more you venture outside of the walled garden, the more you become dependent on that particular vendor. Okay, so it's a business decision on whether you really need that particular feature that only that vendor provides. So here's this diagram. Kind of captures the idea here, where you have your application, your Java application, using this API through the JDBC that converts this into low-level queries that are connected to the database. Right. The set of classes or interfaces that we are of interest here all live under the Java.SQL package, Java library. And here's some of the interfaces of interest. We have interfaces, drivers, connections, statements, result sets, result set metadata, and they all are part of the life cycle of getting a hold of a connection from the database, right? Instantiating it, setting up a session, and then starting to interact using statements, right? Retrieving the result sets and iterating over the rows programmatically, and then or even looking at the meta information, such as what are the list of tables, what are the data types of the fields, what are the fields, right? What are the lengths and whatnot. So let's look at some examples. So the driver interface allows us to register for a particular vendor's specific driver. Right? So each vendor will have their own classes. MySQL will have MySQL dot JDBC dot blah 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 blah, right? And Oracle will have their own, and MySQL will have their own, and SQL Server will have their own. Each one within their own Java packages, right? But they will all be implementing this driver interface, right? And the driver interface is its role is to behave as a singleton, right? That can instantiate itself, right, and register the driver with the Java framework. Once the driver is registered, you can then use it to establish a connection with the database, right? And the connection allows you to provide information about username, password, URLs, and whatnot on how to so that you're going to connect. It allows you to create statements. Allows you to create either a simple statement for and that you just could provide a string with a select, update, delete, right? Or it allows you to create more advanced statements, such as prepared statements, that allow you to um, uh, guard against SQL injection and enforce certain rules that do strong typing. Make sure that dates are actually dates, that integers are actually integers, right? So that you can thwart any attempt at injecting bad SQL. Statements allow you to actually execute or interact with the SQL statements, such as inserts, updates, deletes, selects, and whatnot. You can either execute a query or you can execute an update. Updates are the inserts, the updates, and the deletes, whereas the queries are all the selects, including orders bys and group by and whatnot. Then the result sets represent the rows that come back from the database, right? And here there is a little challenge, right? Because the API makes you think that you're interacting with a collection of objects, at a very high level. Almost like it almost feels like you're interacting with a list or an array. Okay, but obviously you're not, right? Because the rows might be thousands and thousands of records, right? And there's no way that you can instantiate these all these records into memory, right? Obviously there has to be a lot of caching happening down underneath. Nevertheless, it provides API that allows you to iterate, and retrieve the next row, right? Fetch me the next row. The out-of-the-box version of results set allows you to consume the rows in a particular direction, right? Where you're iterating over the rows one at a time forwards, right? There are versions of this that allow you to randomly jump around in the result set, right? Going backwards, going forwards, jumping several number of records forward, jumping back to records, go at the top of the beginning of the result set or at the bottom. Right? So there's a lot of other versions that we'll talk a little later, but nevertheless, it gives you access to a specific record, right? And then access fields in that record, right? Retrieve strings and integers, floats, dates, whatnot. So it allows you to convert the low-level data type in SQL, represented at a high-level data type in Java. Result metadata allows you to interact with the database at a high level that where you can query the meta information about the database, right? You can say, well, give me a list of all the tables, right? And says, well, what about this? Describe this table. I want to know what the fields in this table are, right? And what are the data types of those fields, right? What are their sizes, right? And it allows you to get the how many columns there are, the name of the columns at a high level. So here's the activities of interacting in JDBC. You would first connect to a server, execute a query, then loop through the result set, and then close the connection. So to be able to get our machines up and ready to start connecting to databases, we're going to be using a Java server. It's a Java 2 EE Enterprise Edition Java library. That is going to have all the necessary libraries to be able to interact with the database, including at a minimum the JDBC library. To do this, we're going to be using the POM file to be able to download the drivers of the particular vendor that we're going to be using. In our case, we're going to be using MySQL, right? And MySQL, you can either download the jar file by visiting the MySQL website and looking for the Java SQL connector adapter, right? And you could download it. It's a jar file. You would copy it down in your file system, and then from your project, you would need to add that jar file to the class path of your executable. Another way, a better way, is to instead, since this is a Java project, typically Java projects will have a POM file associated. A POM file is a project model or description of your project, describing what are all the dependencies, right? What are all the libraries that your project depends on, right? And that's what a POM does. And here we're declaring two dependencies. One is the MySQL connector, Java, right? By declaring this dependency, the project will, when you compile and build the project, it will connect to a repository, code repository, and download the jar file for you. Right? We'll put it in a specific directory in your file system, and that directory is in the class path of the project. Right? So it'll be ready when you execute it. The other library that is listed here, it's the data JPA library. We're not going to be looking at it today. That's next week's topic. Maybe we'll get to it today. I don't know. That is an even higher level of abstraction, right? So here we have, MySQL. We have JDBC is a thin layer of abstraction on top of that, and then you have JPA, which is thick layer of abstraction on top of that, right? So we'll talk about that a little later next week. So here's an example, some code that that's connecting to the database using the JDBC driver. In particular, we're using here the MySQL driver. Notice that we're using class.forName. Right? This is going to look for a particular class in the class path, right? And it's going to instantiate it. And once it's instantiated, it will register itself with the Java framework. Notice that this class.forName, even though it's very convenient that you don't have to compile this or link it, it's dynamically finding these libraries in the class path. Notice that it breaks one important rule of Java. Java presumably wants to be independent of vendors. Yes, it wants to not care that your code depends on any particular vendor. But here, right in our code, we have the actual library and the class that we are going to link dynamically. We have MySQL in there, right? So the vendor is right inside our source code. So a more typical implementation of this would make this string configurable, right? As an environment variable, right? That can be configured outside of the application, or part of some XML file or some configuration mechanism that can be dynamically read, that it would not be hard coded in your source code. Right? The other thing here to point out is how the driver manager, once it gets instantiated, is available here as a static instance, right? So that driver manager is now an instance of the MySQL JDBC driver, right? Which is from your point of view, is just an interface, right? But the implementation is specific to the vendor that you just instantiated. So if that class, instead of being com.mysql.jdbc.driver, would have been com.sqlserver.jdbc.driver, then you would be using Microsoft's implementation, right? Or if you were being com.oracle.jdbc.driver, there would be Oracle's implementation of the driver, right? So the driver manager instance would be different vendors, right? Pointing to different instances of a database. So now in the driver manager line here, that .get connection, right, is even though it's implemented by the low-level vendor, it's based off of an interface, right, that is implemented by the vendor. So now we are presumably protected from low-level idiosyncrasies, but not quite. Not quite. Notice that the first argument to this get connection is, again, we see MySQL in there. See that? So this URL presumably is the location of where your database server is running, right? With MySQL or SQL Server or Oracle, you want to dynamically, connect to that database and start interacting with that database. Yes. And notice that again, we have MySQL in there in the URL. Right? The vendor is part of this URL. It's JDBC : then a vendor specific token, right, which establishes the protocol that's going to be used to talk to the database. Right, each database will have its own protocol. Right, each vendor will have its own protocol, and then followed by something that actually looks like a URL. Right, typically this would be perhaps the IP address where your server is running, the port number, and then the database, the actual schema that you want to connect to. Right, the database will have multiple schemas, and you can choose which schema. Right. Also, this URL, the syntax of this URL is specific to the vendor. It's whatever the vendor syntax they decide what it is. So you need to read what the documentation says, what the syntax is, right? Some of them will allow you to provide all sorts of configurations after the URL. Provide username and password, or setting the database in a particular mode, right? So again, it's specific to the vendor. Part of the API is that this get connection should allow as a second and third optional parameters provide the username and password, right, to log into the database. If you don't need username and password, there's an overloaded version that doesn't take the root and password, right? Or the URL should also allow you to provide that your username and password also as part of the URL. So again, the fact that we have the vendor here would suggest that a better solution to this would be that this would be an environment variable, right? Not hard coded in the source code. Instead, it would be part of some XML or environment variable that can be configured outside. Also, obviously, we would not hard code username and password right on the source code. Right? Again, that would be an environment variable that would be different depending on the environment, the machine that you're running on. On a QA machine or production machine would have the different usernames and passwords. Then once you have a connection from the driver, now we have a live session, a live connection to a database, right? Usually these objects, when they get instantiated through the connection, these are very expensive objects, right? These are objects that have to establish a network connection with some other process running halfway across the world. Yes, right. So usually these connections should not be treated lightly, right? Oftentimes these connections are pooled, right? So that you can keep track of them. Maybe a set of connections that you keep around, right? And then maybe it might be shared among several threads that might be accessing the same database, right, simultaneously. Yes. We're not going to talk about it just yet, but typically these connections, they're expensive. We don't destroy them willy-nilly. Once you have the connection, you can create a statement that will allow us to do an inserts, updates, deletes, or retrieval. Right? So statements can take as argument a string. You can say connection.create statement. Here's a SQL statement, and then you can execute the query. You say statement.execute query, and you pass the SQL. That the statement returns a result set. A result set, again, represents the rows that match the criteria of having executed this query on the remote server. One thing to point out here is that we are building the string of the SQL. We're building it by concatenating strings. Yes, we'll revisit this and point out that this is very error prone. First of all, also it's very dangerous. Right, so this opens us up to SQL injection, right? Especially if some of these fields were typed, by some users while they were filling out some form. Yes, typically we would read these forms. The form data would get to this query, and the SQL statements would be concatenations of these strings. Yes, right. And so while they're concatenating, perhaps those concatenations would modify our SQL statement in such a way that instead of being a select, it's an update or delete or some insert somehow, right? That would cause the database to misbehave, right? Or make us lose data or modify data in ways that we would not expect. Yes?
Did you give an example of SQL injection?
There's a joke online. This says, hi, this is your son's school. We're having some computer trouble. It says, oh dear, did he break something in any way? Did you really name your son Robert, quote, parentheses, semicolon, drop table students, semicolon, dash, dash, question mark? The dash dash says that everything else that follows is a comment, right? So anything that was already there, just ignore it, right? So instead, run this. Instead, run this. It says, oh yeah, we call him Bobby Tables. It says, well, we've lost this year's student records. I hope you're happy. It says, well, I hope you've learned to sanitize your database inputs. Yeah, we'll see a couple examples on how a form, as you're concatenating strings, you can use semicolons and dash dashes and to ignore what was the initial query and to instead execute your query instead. And the typical solution to solving this is that obviously you sanitize all your looking for quotations and dashes and any malicious characters that should not be part of the query in the first place, and also strong typing, making sure that if I ask for a date, this is actually date, right? If I ask for an integer, it's an actual integer. I'm parsing all the strongly typed in, and JDBC provides libraries that allow you to do all the sanitation. And so instead of using create statements, we would prepare a statement, a prepared statement, and then prepared statement we would not build. We would put placeholders, and those placeholders would be strongly typed. Yeah, we'll talk about that in a bit. So once we get the result set, we can now iterate over this result set. In this case, we're showing result.next. And so this, what it does is that when we get the result set, we have there's a cursor that is pointing to the actual record that we're currently looking at live, right? And when we say next, the database advances that cursor into the next row, right? And then it's read back into memory. But notice what's happening here, right? This result set represents a single row, right? Well, I'm sorry, the result set represents all the rows, but as you say dot next, right, it advances to the next row, and now you can use the result to read each one of the fields on the particular record or row that you're sitting on. Make sense? All right, but notice what's happening behind the scenes, right? I mean, the results it could represent, logically, it could represent thousands and thousands of records. It could represent an entire table that might be several gigabytes or terabytes long. Yes? So obviously, this result set is not instantiating, these thousands and thousands of records in memory. There is no way that we can map, terabytes of data into some gigabytes that are associated to your application that is running in memory. Yes? So this result is a fairly complex machine here that is maintaining a cache, right, and fetching perhaps 10 rows, caching that into memory, and then allows you to iterate over them doing .next, yes, and providing you these 10 rows. When it reaches the end, or when it's getting towards the end of the cache, it goes out and does another query, right, for the next 10 rows that are in the database, yes, right, and brings them up to the cache, right, and obviously at some point it needs to do some cleanup, right, because if it has thousands of records in memory, it'll soon run out of memory, right, so it has to throw away records that are no longer that you've already iterated over, right. So for instance, by maintaining the constraints that you can only move forward, right, I could do a lot of optimization. I can just, once you've read a record, I can just throw it away. Right? I don't need to keep it around. So I can do cleanup as you iterate forwards towards the as you go forward. Okay. Nevertheless, it provides this high-level conceptual iteration over the rows, right, in memory, right, as if you have everything in memory. You don't have to deal with any of this, right? All the caching happens behind the scenes. So this is retrieving each one of the fields, right, and then storing them locally on a local variable. The very last thing after you've done iterating, you need to close all your connections, right? Typically, these connections can stay live, right, for minutes or even hours, right? If you do not programmatically release these connections could still be live, and the remote database only has so many connections, live connections to give out. Yes. So if you if you forget to close your connections, and you're in a development team, and it's 10 of you, doing connections over and over, and you're testing this, you will soon run out of connections, right? And somebody will yell out, "Hey, who's not releasing their connections?" So don't be that person. So you should release your resources as you go, right? These are all remote resources that live elsewhere. Uh, Typically at the end of the typically we would wrap all this code inside of a try-catch block, right? That can throw all sorts of network and SQL exceptions from the database. But usually at the very last thing that we would do in Java is to make sure that the connection is closed. We check if it's not null, we close it. If there is an exception, the connection would still stay open, right? So make sure that to stack trace it and debug what's going on. Of why is the connection not being released? We can one way that that the databases how we can configure the database is through what are called properties, and these properties, many of these properties are standard in the in JDBC. Some of these properties are only make sense or are for specific vendors, right? That have certain properties on whether you can drop certain tables, on whether you can alter things or run things using stored procedures and whatnot. Right. So these, as I mentioned earlier, these strings are vendor specific. For the updates, the statements is a little bit different. Instead of using execute query, you use .execute update, right? And unlike execute query, execute update does not return a result set, right? There's no rows that come back. It does return a status. It can return a status, which is, I don't believe I have it here. It can return a status which you can assign to a variable, and that status will tell you whether it's successful, how many rows were affected, right? It'll give you some mechanisms that would allow you to know whether the update was successful or not. And as always, you would close the connections. Also, also something to consider is that the next, right? Once you get the result set, the cursor is not actually pointing at any row in the remote database, right? Instead, it's pointing to what we refer to as a before first, right? Before the first row, right? It's a logical position in the database. Not until you do the first next on the result set will the cursor actually advance to the very first row, right? So it would be a mistake to try to read something from the result set before making at least one next. Okay. Now it makes sense when it's a while loop because there's a whole bunch of them, and there's a whole bunch of rows. Obviously, you're going to have to iterate over it. So obviously, you would put it inside of a while loop and do a next, right? But it's a little less intuitive when the result set comes back with a single row. Maybe you're retrieving the person who's currently logged in, right? And it's a single person because you have a username and password, all right? And it's a unique identifier, yes? And it comes back with a single row. There you might be inclined not to do the next, right? It says, well, I only got one result. There's no need to iterate over it. Well, wrong, right? You should perhaps do instead an if result set dot next, right? That would advance the cursor to the first record, and then you can start reading the single record. Make sense? Right? So careful there. Here's an example of using metadata to query for meta information from the database, right? I'm not querying any particular record. I'm not or any particular row or field or anything like that. Instead, I'm querying the entire database. Here I'm asking, give me your tables, right? Once I give you the table, give me all the fields in that table, right? Once I have the field, give me all the data types, Give me the size. How many integers? How many characters is this varchar? So you can ask about the meta information about the table, the schema. You can ask about the schema. Here we've done a query. We've done a select statement, and the result set. Not only does the result set allow you to iterate over rows, it also allows you to ask things about the meta information about that table. So for instance, here we're using the result set to get the metadata, the result set metadata. And the metadata has things such as how many columns does this table have, right? How many, what are the fields? And now I can iterate over all those fields, right? So maybe this is a great mechanism for creating a generic database interaction, right? Where I don't know which fields, just I want to iterate over all the fields. I don't know how many there are. Okay, somebody's having fun. I am. So here we're iterating over all the fields, right? All the columns. And as we're iterating over the columns, we're querying each column, say, hey, column, what's your name, right? So here you'll find, it's username, password, first name, last name, social security number, date of birth, right? All the fields in the user table, for instance, yes, right? You can also ask what size the display, how many integers are you? How many digits? Are you a date? Are you a varchar? How many characters is the varchar? You can ask for the size. You can also ask for the data type. What are you? Are you an integer? Are you a varchar? Are you a date? What are you? Are you tiny int? What are you? Okay. Based on that, we could do all sorts of things. We can say, okay, well, now that I know you're an integer or varchar or whatever, right? I can just maybe print out all the data types here. So here's an example of a SQL interpreter, right? If we don't like MySQL as a console, we can write our own. And so here's a really trivial one. Connects to a database and allows us to query about tables and query about which tables you have, describe a table. I want to see all the fields, the data types, and whatnot. So here it is. We have the driver. We connect to the driver, and the buffer reader so that we can read from the keyboard. And here we're printing out the SQL command line, and we're reading from you typing at the command line. If you type exit, we stop. Otherwise, if your statement that you write starts with a select, then I know you're doing a query, right? If instead you type anything else other than a select, then it must be either an insert, update, or delete. Make sense? I'm sorry, we have another class on the left, right next door. Looks like you're having a lot of fun. I'd rather be here. We'll see. Okay, so it's listening for select or updates. Here if it's a query, then the command is being passed along. It creates a statement. It creates the execute query with a CMD. It iterates. Once it executes it, it grabs the metadata. It grabs how many columns it has, and then it just iterates over all those columns, displaying the names of the columns at the top. So it's basically going to display a table, right, from the result set. Yes, right. First is displaying the field names, right, all the column names, and it's also formatting it so that the columns are going to align nicely with the results, right? So that if you set an integer 11 or varchar 25, right, that's how much space is taking, right? So that all the results are going to be nicely aligned with the headers. So here's just printing out the headers at the top with the column names. Then it's going to actually iterate over the results. Here's the result next. I have the result set, and I'm going to iterate over the columns. And for each column, I'm going to get the name of the column at that position. I'm going to get the type and the size of the column, the actual data, right? So depending on the data, I need to be able to parse it, right? It says, where are you? Are you an integer? I need to do a get int. If it's a string, then I need to get a string. Notice that this doesn't take into account dates. It doesn't take into account all the other data types, right? It's only integers or varchars. So it's reading from it and it's displaying it in a loop. That means that it's iterating over all the columns, right? And it's displaying all the values in a nice tabulated format. The update is slightly different. It creates a statement. It uses the command to execute the query. The query is going to return a status information about how many records were updated, right? Whether or how many were deleted or updated or inserted, right? It tells you and says, well, so many records were processed, and if there's an error, it prints out the message.